But today, we're going to talk about phasors and mesh.
It's
and
just an
you'll remember that all
organized
that,
way.
that mesh analysis
It's just an
is
organized way of doing KVL, which is another way of saying that the sum around any mesh and the sum of the voltages are going to be equal to zero. So there's a few steps to this. Unlike nodal, you don't need to define a ground. What you do need to do is to define all your meshes. So you're going to create your I1 and your I2 and so on variables around every mesh. And then for every, and sometimes I get questions about how do you create, what direction to create these variables, because they've got to have a direction to them. And these directions, if you know what direction current, absolutely, if you're positive you know what direction the current circulating, draw it in that direction. And if you don't, just choose a direction arbitrarily. If you choose the direction wrong, you'll just get a negative answer. And then because you're trying to sum voltages around the loop, mesh loves circuits with lots of voltages, lots of voltage sources, because then you know what that voltage source is. It doesn't necessarily love current sources. So for every current source, you're going to have to do something. You're going to reduce one unknown. There's two choices about how you're going to reduce your unknown. One option is if the current source is not shared. And this is your favorite option because it means you get to simply just reduce one current source with no super anything. So here's a current source. It's not shared by anything. We've got your current loop going around here. And since you know that that current has to be 2 amps, don't call it I1, call it 2 amps. Now there's more stuff. Let me get it in the right color. Now there's more stuff out to the right. So there's a lot more stuff out here that I'm not drawing. And our other option is if it is shared. And anyone tell me if it is shared, actually Caleb, tell me if it is shared, what's your approach?
The current source is shared, you got to do the super mesh.
That's it exactly.
By you have your one equation with both of the currents, and then you do KCL at the node.
That's it. So the idea here that if it's shared is, before say we called this current I1, and then we might have called this current I2. And there's more stuff to the right and to the left of this. And afterwards, the problem is we can't do a KVL around here because we'll be summing up voltage drops here and we'll get to this current source and we won't know what the voltage is across this current source. So we're just stuck. So the way to get around it is to totally get around the whole thing, do a big super mesh around the whole thing. And then let's say that we've got let's call this super mesh I1 on this side. Now I've got I1 circulating around here, 2 amps peels off it. So Cole, what are we left with on this side?
It'd be I1 plus 2, right?
So it's gonna be,
right? I1 minus 2.
It's going to be one of the two. And so here's 2 ways to figure this out. One way is using intuition, One way is using math. Intuitions, we've got I1 coming in here, 2 amps peels off, so what's left?
I1 minus 2.
Minus 2, because 2 amps peeled off. And we'll have I1 minus 2 going around this whole loop. And then using intuition, 2 amps gets injected into it. And that brings us back to our I1, which matches what we've got on the left. Here's another way to figure that out. Let's say sometimes you just look at it and it's not making sense. You're not sure what's happening. In that case, just do KVL. You want to know you're not sure what this is. Just call it, IX, say. And sum all the currents exiting the node. The current exiting the node here is minus I1. The current exiting the node here is 2. And then the current exiting the node over here is IX. You know all that's equal to 0. And this is what Caleb was referring to earlier. Now, if you solve for IX, you can do it by putting these two on the right side and you get I1 minus 2. So whether you're going to do it by intuition or by KCL, you figure out what these currents are on this mesh. And now that you figured out what the currents are around this mesh, now when you're solving the voltage drop across resistors here, if it's to the right of the side, you'll use I1 minus 2. And if it's to the left, you'll use I1. Last issue is that if there are any dependent sources, you know you need an extra equation. And there's no one rule to find that extra equation. It's often using Ohm's law, though. And then the last step is to matrix solve. And that worked great using TI 84s and below before we had complex numbers. And for complex numbers, you need that TI 85 or above.